All right, we are going to talk about our first kind of bond, ionic bonds. This class we're going to focus on how to create and name ionic formulas and compounds. All right, so if you can create a formula or name an ionic compound, you will be showing that you got what you were supposed to out of this lesson. So particularly if you could come up with a formula for calcium fluoride, that means you got this. All right, so quick review. Which of the following would represent an ion, an element from group 2A? So this is remembering that group A ion pattern. I keep mentioning it, that it's going to come back to haunt you if you don't have this written down somewhere, so you can real quick look this up. Go back to the monatomic ion recording and get that down. But you should be able to, as soon as you know it's an A group ion, you should know that it's going to have a specific ion charge that it'll form. And 2A happens to form +2 ions. So C is the correct answer here. So ionic bonds are bonds that involve a transfer of electrons. All right, so something's got to lose an electron and something's got to gain an electron, or multiple electrons. All right, so ionic compounds form so that each atom, by gaining or losing electrons, has an octet of electrons in its highest occupied energy level. All right, so what number does that sound like? All right, so octet is 8. And that's kind of the goal. This whole octet rule and trying to get to 8 is the emphasis behind all types of bonding. In ionic bonding, we happen to either completely give up electrons or completely gain electrons in order to do this. All right, and we've talked about how this works. Your metals will lose electrons to form a positively charged cation, and then your nonmetals will gain electrons, and then that positive, negative opposites attract. So that's how these bonds form. So the quintessential ionic compound is sodium chloride. Good old table salt. All right, in sodium chloride, you have sodium, which is 1 valence electron. It's in group 1A. It's going to give up that 1 valence electron, all right, become sodium plus. When it gives away this 1 electron, it drops down to the shell below, which you can see has 8 electrons. All right, and then chlorine, all right, which has 7 valence electrons when it starts, it's going to take that electron, and when it does that, now chlorine has 8 electrons in its outer ring. All right, and then you've got sodium +1, chlorine -1. Those positive and negative charges attract each other, and ionic bond forms. All right. So these ions, because they have opposite charges, attract. The key to making an ionic compound, this is something you want to make note of, is that the overall charge must equal 0. So these atoms, these ions, are going to form bonds in the appropriate ratio to cancel out their charges. All right? Sodium chloride is easy because you got +1 and -1. But sometimes it's not as straightforward as that. So, when you run into ionic compounds, there's going to be 2 ways you can represent it. You can represent it verbally, all right, by naming it like what you see on the board: magnesium chloride, sodium oxide, aluminum sulfide. All right, if you notice, the first word is written as is, and that's always going to be the metal. All right, so the metal always comes first, and you just write out the metal name, the name of the element. All right, there's no change to it. It's just magnesium, sodium, aluminum. The second word is always going to be your nonmetal, and that word is going to be changed a little bit. You're going to chop off the end of the word and throw on an "ide." All right, so if you're reading these and you're trying to figure out what element is in here, you got to pay attention to the beginning of the word. All right, so chloride, that means this element is made out of, we know what magnesium is. And then chloride means chlorine. All right, or the next one is sodium, which we know is Na, and then oxide sounds like oxygen. Aluminum, we know really easy, that's aluminum. And then sulfide sounds like sulfur, and sulfur is abbreviated as S. All right, so so when it comes to the names, you just write the metal, and that always comes first. And then the non-metal, you're going to chop off the end and throw on an "-ide" ending, and that comes second. Quick review. All right. This group A ion pattern, I keep telling you it's going to come back to haunt you. Make sure you have this down, because this is going to be necessary for forming these ionic compounds. All right. When it comes to creating the formula, or the formula unit, you may see it referred to, there's 2 steps to this as well. First, determine the charge of the 2 ions that are present, and then combine them in the appropriate ratio that cancels out that charge. All right, so for example, we know that this first one is magnesium. All right, magnesium happens to fall in column 2A on your periodic table, so that means it's going to have a 2+ charge. All right, and then we have chlorine, which happens to fall in group 7A, which has a +1 charge. All right, so looking at that, we have 2 positives and 1 negative. If I combine those, I'm going to have an overall charge of +1, which is not 0. All right, so which one do I need to have more of in order to make sure that we cancel this out? I'm going to need 2 chlorines. All right, so the formula for magnesium chloride, when I write this out, is going to be MgCl2. All right, when you write the formula, you do not need to include the charges in there because they cancel out. All right, as long as you do it correctly and you cancel out the charges and they end up becoming 0, then you don't need to write the charges in there. All right, so let's do that again. We've got sodium, all right, that's Na, and that is in column 1A, so that's going to be a +1 charge. Then oxide is oxygen. Oxygen is in group 6A, which forms a -2 charge. All right, so pause here for a second. See if you can figure out what the formula should look like at the end. So, hoping you're noticing that we are short a positive charge, so we're going to need 2 sodiums to cancel out the -2 on the 1 oxygen. So our formula is going to be Na2O. All right, so look up the charges for aluminum and sulfur. So aluminum is in group 3A, so it's going to be 3+. Sulfur is in 6A, it's right below oxygen, so that's going to be -2. Now, if you're really good with numbers, you might be able to pick out the ratio right off the bat. But if numbers aren't your strong suit, work your way slowly through this. All right? I see that we have +3 and -2, so I have excess plus. So I'm going to need I definitely need to increase my negative. So if I throw in another sulfur, I'm going to have -2 plus -2, which is -4, and then aluminum 3+. So that doesn't outright fix things. So now I need extra positive. So let's throw another aluminum in there. All right, so now I've got 6+ and -4. So I need some more negative. And you know what? Eventually, I do come to a point where these cancel out. So if you look at this, I've got 3 plus and 3 plus, which makes 6 plus. And then 3 negative 2's, which makes negative 6. So this ratio, 2 aluminums to 3 sulfurs, gets me down to 0. All right? And this is actually as complicated as it gets. You're either going to have real obvious ones, like the first two, all right? Or you're going to get lucky and everything's going to be equal right off the bat and you only need one of each. But the worst it'll be is if you run into when you have like positive 3 and negative 2, or maybe negative 3 and positive 2. If you have that 2-3 combo, just remember, you need to get the plus 6 and negative 6. All right? And then, so our formula here is going to be Al2S3. All right? This tends to be one of the trickier things in this unit, is getting how to write these formulas down. So if you are struggling with this, make contact, because you are going to have to repeat this process and explain yourself on the written part of the test. All right, so here is a place for you to practice writing the formula and naming some. All right, I'm only going to do a couple. You should be capable of doing all of these, but if you find that you just have no idea how to do any of this, that's where you need to come get help. All right, so I am going to do calcium fluoride fluorine and calcium, and barium and nitrogen. All right, as just some examples for you guys. So pause it, try those two. And then if you get all that right, awesome. If you don't, try a few more, make contact with me. All right, so to name these, the naming part's pretty easy. First, figure out which one's your metal. All right, that's going to be your calcium. So the name is going to be calcium, and then I'm going to write fluor, but instead of "ine" at the end, it's going to be "ide." All right, now to get my formula, I know that Ca, column 2A, so it's 2 plus, fluorine, in column 7A, so it's fluorine minus. So I've got a missing negative charge, so I'm going to need 2 of those fluorines to cancel out the 2 plus on the calcium. So my formula is going to be CaF2. All right. So barium and nitrogen, I've got barium's my metal, so it'll be barium nitride. And then barium is also in column 2A. Nitrogen is in column 5A, so that's going to be a 3 minus charge. All right. If you remember what we just talked about on the last slide, when I see 3 and 2, that means I got to get to a positive 6 and negative 6. Or I can work my way the long way. All right, so if I add an extra barium, that increases my positive charge, but it doesn't make it equal. Because now I have extra positive, so I'm going to have to add another nitrogen. But now I have too much negative, so if I add one more barium, lo and behold, I have 2 plus 2 plus 2 is 6 positive, 3 plus 3 is 6 negative, so my formula will be Ba3N2. Again, this is something you have to be able to do, and you're going to do this a lot. Multiple choice and written. So, if this doesn't make sense, come get help.